What if uploading one image file could instantly surface every related report, spec sheet, and past version across your entire company? Today I'm showing you the full stack multimodal knowledge base I built to make that real, using the brand new Gemini Embedding 2, FastAPI, and a React frontend. Welcome to Made by Agents, my name is Tobias, and let's get started. So in this video I'm gonna show you how to build a multimodal RAG knowledge base which can handle all kinds of documents, images, audio, PDFs, video, and text obviously, and you can also chat with your documents and it can pull out everything for you. So what's new is that it can handle all of these different formats and not only text, and for that we are using Gemini Embedding 2 and ChromaDB to storing the vectors, and the rest is common existing software, FastAPI for the backend, React for the frontend, and server-send events. The problem is that most knowledge bases, they can't interpret images, they can only store text. So the moment you want to ask questions about your image or you want to upload an image and find similar images and stuff like that, you are kind of stuck with the traditional stack. Yeah, imagine you have PDFs with some graphics and you want to pull specific pages. It's very hard to do with text-based RAG knowledge base. So text-only RAG is kind of blind. It can see diagrams, charts, or screenshots. And imagine you have designs somewhere in Figma, specs in Notion, and reports in Drive. You can't really bundle everything together in one single knowledge base because of this limitation. And the way to solve that was to use two completely different models. One model, usually something like a clip, handles images and tries to align them with text. And then you have a completely separate text embedding model for your document. And you end up with two different vector spaces and you have to write a bunch of custom logic to combine the results. The architecture that I'm going to show you is completely different. The stack looks something like this with 4 thin layers. First we have the traditional React UI with TanStack query. Then we have a FastAPI Python backend, and then we have our two scripts. One is for ingestion and one is for the retrieval logic. And then we have the vector database. In this example I'm using ChromaDB because it's quite simple and easy to start with. And we have just one model for everything, which is Gemini Embedding 2. And this allows us to ingest all kind of documents into the Chroma database. Then we can search over it with text or image queries, and it looks up the vectors and gives us the ranked results. And then we also have a chat with streaming support. Gemini Embedding 2 is different because it's natively multimodal. It's just one single model and one single vector space. Text, images, PDFs, video, even audio, they all get projected into the exact same embedding space. That means when you search with text, it can directly find the most relevant images or PDF pages without any extra code. And when you upload an image, like a product design, it can find related text documents or other images because they're all speaking the same semantic language from the start. And Google built this using the so-called Matryoshka representation learning, or MRL for short. And what that means is pretty cool in practice. The model outputs a 3072 dimensional vector by default, but because of how it was trained, you can safely truncate that vector, for instance, down to 768 dimensions, and you still get excellent retrieval quality. So I'm using that in this project, and this gives us a great balance, really strong semantic understanding while keeping the vector small, which means faster searches and lower storage costs in Chroma. There's just one constraint. When you upload PDFs, the limit is 6 pages at once. So when you have larger PDFs, you need to split them. And for videos, the limit is 120 seconds. What I did in my example is that I split the PDFs by page by page, because this way I can retrieve the exact page with my query and I know exactly which pages it came from. And for video, you have two good options. If the clip is under 2 minutes, you can embed the whole thing directly. For longer videos or when you want more precise retrieval, you can extract frames at regular intervals and embed those frames as images and store the timestamp along them. That way you can surface the exact moment in a video that's relevant to a query. Yeah, let's see this in action. This is a simple demo that I quickly wipe coded together, and I already uploaded some files here. But yeah, the first thing to do is upload files, and I have a few more examples. Let's take this 100 million offers book, for example, from Alex Hormozy, and this will take a while because it has hundreds of pages, and like I said, I'm splitting it page by page. And while this is uploading, I can show you the library here, and it will appear here, and stuff that I ingested, some images here of a motherboard, of a chip, then some PDFs with small text and formulas, and also some short videos, some screen recordings that I ingested here. And then we have a chat window here where we can chat with our AI assistant, and then we have a search where we can search directly. And besides of text queries, we can also upload an image and search with this image. So now it has ingested that one file, and we see here a PDF, 215 pages now in this case, and I can just shoot some queries now, and I'm gonna record this in real time so you see how fast this is. And I can type something like photo with a chip, and now it's giving me the top 8 results with the highest probability or highest match, and I can adjust that. But I see here that the highest probability is this one here, and it's exactly what I want, is the photo with the chip. And now I can also try photo with a motherboard, and boom, voila, it's pulling up this one here. And now we can also search with images. So I took a screenshot of a graphic, and now it's pulling up the 100 million offers book and the exact page where this graphic appears. So it appears on several pages. Then we can also chat with it. We can ask something like graphic where Hormozy explains the 100 million offer model, and then it gives us a text summary and also relevant pages here. And I can ask something like the video where I show AI benchmarks, and now it's retrieving the screen recording that I took about AI benchmarks. Or ask something like how to create a good habit. Oops, typo. To create a good habit, and then it's summarizing the habits cheat sheet that I ingested here. Yeah, how to create a good habit. So that's how it works. So you can text query, it finds images and PDFs. You can image query and it finds everything related to that image, and you can chat with vision. So what's next? This is just a quick demo, but you can think about adding timestamps to videos and video frames, then creating an OCR pipeline with more capable OCR models that are able to understand handwritten letters and very complex tables and stuff like that. And what would be also cool is adding agentic workflows to it so that your agents can query this knowledge base. How did I build this? So I'm usually always starting with a task list when I create stuff like that. So I let my coding agent create a detailed plan step by step, and I let it write this for coding agents. So the tone is imperative. That means I'm not saying, hey, you should do it like this, or it could be like that. It is really written for AI agents with clear instructions. So you must do it like this, do it like this, do it like that. And this way it's shorter, it's saving tokens. And on the other hand, it is very clear what the agent should do. And in my initial prompt, I roughly described the architecture that I wanted to have, and I did some research about that beforehand, and it added this diagram here in this task document with the key features and describing the different components like server-side events, then the exact tech stack for the backend and for the front end, and also the layout and code examples, the API endpoints that we need, schemas, and a lot more stuff. And then the implementation phases. So instead of telling the coding agents to do everything at once, you can go step by step, and this way you won't fill up its context and it will be usually more accurate. So you can say start with phase 1, the backend skeleton, then phase 2, the backend routes, then the front end, then the front end hooks in API layer, and the front end components, then integrating both, and then optionally Dockerizing it. Then we also have a verification checklist here, and then also an out of scope list with stuff it should not do right now, so that it won't hallucinate and add authentication and whatever stuff to it that we haven't asked it to do. Yeah, and I usually put this task list in a docs folder in this code base, and here it created the backend files with the routes and different scripts, and then the front end with components, the UI components, the hooks, and some utility functions. And that's pretty much it. So everything you saw is open source. Besides of the Gemini model, I'm gonna create a template from that knowledge base I just showed you and upload it to GitHub. So you can check it out, you can download it and use this to build your own knowledge base. As always, thanks for watching and see you on the next one.